Good morning, everyone. We're going to get started now with some announcements. Welcome to the Wednesday morning plenary. I've got some reminders for you. So if you're joining us virtually, please make sure you mute. If you're joining us in person or virtually, we're expecting a really jam-packed schedule today. We have messages from all of the science collaborations, plus lightning stories from our students. So the best question mode is going to be in our Rubin 2022 PCW Slack space in the channel that is for this plenary session that I put down here at the bottom. This way you can ask questions on the fly at any time of any of our speakers as we go, and they'll be able to answer them in the Slack channel as well. As another reminder, we do have a code of conduct for this meeting, which you read and signed when you registered. If you do experience or witness any incidents of bullying, harassment, or aggression, please do reach out to the people listed on this slide. And as every day, thank you for wearing a mask, and remember to check people's name tags for their COVID comfort levels before making contact. Today, we'll have lightning stories from our LSSTC Enabling Science graduate students at the end of this session, followed immediately by the poster session, which is out there. So you'll be grabbing your coffee and then heading over to interact with our graduate student researchers and talk about their wonderful LSST-related science. Today is the unconference. It's in the very last slot of the afternoon. This has been an annual tradition at the PCW for a long time now. You will find the unconference board pretty much right outside those doors over there. You can still propose session topics and or vote for the topics that you would like to attend. We're going to accommodate as many suggestions as possible. The voting is not to pick a winner. The voting is just so we assign the biggest rooms to the most popular sessions. So all of these rooms will be assigned by the end of the afternoon coffee break. I'm going to write the room assignments right on the board, and I'm also going to post them in PCW-announcements Slack channel. So that's where you'll find out which room it is that you're going to be going to. As a reminder, on Friday, the plenary is the breakout summaries. The slides for the breakout summaries are available for everyone at ls.st/r4g. The participants of the unconference breakout sessions are encouraged to make a slide for that deck and to present it on Friday, but you don't have to. It's optional for the unconference. However, it's not optional for all of the session chairs of our other breakout sessions. So please make sure that you get your slide made as soon as possible and by Friday morning at the latest. If you have any dietary restrictions at all, please just go ahead and ask a server for help. If there isn't anything out on the tables that you can eat, I'm hearing lots of reports that servers are pretty responsive in getting you what you need when you need it. So do reach out and ask if you don't see anything on the table for you. And now I want to invite Fed. Oh, you're here.
Hello, I just want to take a second to announce another conference related to LSST and Rubin, LSST at Europe 4. It's going to be in Rome in October 24th through 28th. There is a website that is LSST Europe 4, and you can sign up. We have limited participation in person because of COVID. If you have already signed up, we're shooting to reach out to you by the end of this week. The priority of the organizing committee in selecting participants, in spite of the in-person limit of space, is to make sure that our participants cover a diverse set of science and also represent a diverse set of identities. We have just published our list of invited speakers. We're recruiting a few more, so please come to Rome. It's going to be at the very historic venue of the Accademia dei Lincei, and I hope to see you there.
Thanks. Okay, now we start our science collaborations plenary. So this is also an annual tradition where we have each of the 8 science collaborations come give a short presentation. They give the presentation to you, the science community. This is also their annual chance to speak directly to the project, and also their annual chance to talk to each other, to share their milestones, their celebrations, and also the challenges that they face, and oftentimes it's challenges that they have in common. So I'd like to have a big round of applause as we invite the new Science Collaborations Coordinator, Will Clarkson, up on stage to lead this session. Thanks.
Thank you. Can you hear me? Yep, sounds like it. Thank you, Melissa. Thank you, everyone, for coming in on such a nice morning. Yes, so to help you organise your listening for the next until 10:10, here's what you can expect. I'll give a brief overview about the science collaborations and some updates from the last year. Then you'll hear a little bit about a funding programme that cuts across several science collaborations, since that was discussed a little bit in the Ops Plenary yesterday. And then we'll break into presentations from the individual science collaborations. So we'll do our best to keep to time so that the students have plenty of time to present, starting at 10:10. So, before I forget, 3 of the presenters are actually not co-chairs. I'd like to make sure we acknowledge Kat Volk, Matt Wiesner, and John Franklin Crenshaw, who've all stepped up to present on behalf of their science collaboration chairs that couldn't be here in person today. So thank you very much, Kat, Matt, and John, for that. Okay, so who are we? We are a federation of independent international researchers organised into self-managed teams by science area. You can see from the slide here that we cover scientists all over the world, and the collaborations are designed to be as inclusive and as accessible as possible. There are no membership fees, there's no requirement to be affiliated with any organisation, there's no requirement on time commitment, at least not at the federation level, for membership. And as part of the federation process, Rubin actually relaxed its previous restriction that you had to be a data rights member to join the science collaboration. So there's no restriction from Rubin on whether you have to be a data rights holder to join a science collaboration. The science collaborations themselves do have a few differences there, but you can find that out from the individual science collaboration websites. So what do? We arrange ourselves to really do the following main goals that you can see on the slide here. To prepare for LSST, to provide expert advice to Rubin, the project comes to the science collaborations for input on a number of important issues, to train, educate and engage the scientific community, to help fundraise for our teams and their projects, to develop and implement research inclusion practices, and to collaborate on software development, including in-kind contributions. So I'll show a few highlights of this before I give it over to the individual science collaborations. The collaborations have a long history of helping to set the scientific direction for LSST, going at least as far back as the science book that you see flashed up here. But beyond that, the science collaborations are also working on determining for themselves what they need to do to get ready for LSST and to use LSST data to advance their science. And so the collaborations work on these scientific roadmaps that communicate both to each other and to the outside world what it is we want to do and to organise our efforts. An important aspect of this sort of cross-collaboration is we have workshops and other collaborative efforts to enable collaboration between groups that might not otherwise see themselves as collaborations. I'm showing an example on the top right here of a paper that was enabled by one of these workshops where members of different collaborations got together to work on an interesting science issue. And of course, we participate in the in-kind contribution as well. To date, I believe there are on the order of 80 in-kind contributions now with a science collaboration as primary or secondary recipient. And so the collaborations we're involved in reviewing those and in actually helping to determine the direction. And we continue to be involved in actually incorporating them into the efforts of the science collaborations. In terms of expert analysis to Rubin, I'm just going to show one example that has a pedigree of some years now, and that's the observing strategy. The project's been extremely gracious in reaching out to the community to help determine what observing strategies will cause the least people, the least unhappiness. And you can see here some examples of efforts that the collaborations have contributed to help sort of solve that problem. I think you'll hear more about this later in the presentation, so I won't dwell on this much, but one of the recent highlights is this special focus issue of the Astrophysical Journal supplement series, where these observation strategy ideas are being codified and published, and that's thanks to Fed Bianco, who has led that effort. One example of training and involvement and engagement that we're involved in is Science Collaboration's involvement with the LINK program that LSSTC is running. By my count, there are on the order of 51 mentors for the LINK program from Science Collaborations. It's a nice example of how sort of we are helping, I think, to engage and train new members of the community who would want to work with Rubin. One development since the last year is the establishment of a diversity, equity and inclusion council, all across all of the science collaborations. All of the science collaborations have some level of DEI efforts, whether that's a DEI committee or whether that's a few investigators. We don't have a website yet for this PAN collaboration council, but this has started to meet now this summer. And this exists to do the following things: to help with sort of coordinating DEI efforts across the science collaborations, to help share knowledge so we don't need to reinvent the wheel, to coordinate them with Rubin and Noir Lab's efforts in the same direction, and to provide a sort of PAN collaboration repository for DEI practices, resources, and so on and so forth. So we're working on the charter now for this group, so we expect to post the draft charter for this DEI Council later in this year, probably during the fall, and input will be very much welcome for that. One of the advantages, I think, of being a member of an science collaboration is that we're plugged into all of the sort of parts of the Rubin ecosystem. This is a fairly complex diagram, which I haven't got nearly enough time to explain, but the coloured circles represent the science collaborations helping each other collaborate. So we actually have workshops and other collaborative efforts to help us sort of share efforts. All of the grey ellipses are examples in which the collaborations have an input and an output from the Rubin ecosystem. For example, once a month there are these meetings where the project presents to the science collaboration chairs, and we can ask them questions about how things are going. There are commission liaisons for each collaboration. There's a DM liaison for each collaboration. The SCOC has a liaison for each one of these. And so communication, I think, is quite good between the collaborations and the project. So you can think of us as a collaboration of 2,000 people with the ear of the project. And so by being a part of this, you can be part of that sort of that communication. So the last thing I want to say before I hand over is the main challenge I think I can say accurately that the science collaborations face is funding. We are extremely grateful and acknowledge funding support from the LSST Corporation, which continues to be very helpful, including some infrastructure support for example, collaboration meetings or for SLAP, and small grants, for example, the enabling science calls that have happened over the last few years. But most of SC's science is not currently funded. Our big challenge at the moment is how to raise funding at the kind of level that can fund, for example, grad students or postdocs. And that's a key priority for us as the Rubin collaborations going forward. We are working to try to help the community get success in this regard, both in terms of the kind of documents to help with fundraising for PI-type grants like NSF AEG. But we've also started to try to think a bit bigger and leverage the fact that we have 2,000 people across 8 different science areas to try to fundraise at a bit of a larger scale. So I'm going to yield the rest of my time to the PI of one such successful program that's across multiple science collaborations, and that's Rachel Street. So, Rachel, if you're ready.
Hello, everybody, and thank you very much for the opportunity to tell you a little bit about the Preparing for Astrophysics with LSST program. This was a multi-SC program, the first of its kind, a joint effort between transients and variable stars, stars, Milky Way and local volume, and the solar system science collaborations, with generous support thanks to the Heising-Simons Foundation. It was a one-year program, so we consider it hopefully a pilot program, and I'm indebted to the co-chairs of all 3 science collaborations for their help in designing and running this program. The specific goal of the program was to overcome some of the barriers to entry that prevent people getting involved in Rubin research over a number of different facets that we felt were particularly problematic. I'd like to spend a little bit of time on the main aspects of the program, but if you want to learn more about it, please visit the website where there's full comprehensive information. The lion's share of the program was dedicated towards our Kickstarter projects. We invited all members of all 3 science collaborations to propose projects that would enhance their preparations for Rubin research. It was open to members worldwide, and the topic of the projects could be anything, but we specifically incentivized collaborative projects, and in particular, collaborative projects that enabled people who have historically not been able to participate in Rubin or even in astronomy in general to get involved. And I'm very proud to say we were able to support 35 different projects with PIs coming from 9 different countries. Many of those projects were international in nature, and we're supporting over 150 researchers as a result of that. The topics of the projects cover everything from data analysis to the accessibility and the visualization of data, to founding new Rubin science communities, data access centers, and everything in between from all 3 of the science collaborations and all of the research that they do. Student training was a major aspect of the projects that we were able to support, and we placed a real emphasis on developing meaningful, lasting partnership, especially with underserved communities and with newcomers to Rubin. We also identified that software and computing is, of course, increasingly essential to astronomy research in general, but Rubin in particular. Now, we were fortunate to coincide with Rubin's great efforts towards democratizing access to impressive computing facilities over a range of aspects. For example, the Rubin Science Platform, the data access centers, and of course, most recently, the link computing facilities. So we focused instead on providing access to software development training. Most astronomers get some level of software training, but most of us don't get professional grade software training. And in the Rubin era, we're increasingly finding that's not enough. And access to that kind of training, the quality of it varies dramatically depending on what institute you're at. So we got access to training courses that were professionally developed, not just in software development training, but also in the design of software and software requirements engineering. And we held a number of workshops that were held entirely virtual to enable more people around the world to participate, including in new communities that have not been involved in Rubin, including, for example, in Ethiopia. And all of the materials for those courses are now freely available from our website. That includes the course content itself, the session recordings, everything is available from the URL. So I encourage you to check that out. It's a really useful and informative course. The last aspect I'd like to cover is that we supported the publication of science research. This is another area where, depending on the institution you're at, you may or may not get support to cover the costs of page charges in major journals, which can be quite substantial. We have funding to support the publication of a wide range of research, but in particular, we have earmarked funding to support the publication of the science collaboration roadmaps themselves. And in particular, we have funding to support the publication of survey strategy papers in the APJS focus issue that Will mentioned earlier. And I want to stress that this opportunity is actually available to all members of the Rubin Science community, not just the 3 participating science collaborations. And that opportunity will be open over the course of the next year. So if you have survey strategy research that is ongoing that you would like to publish, please get in touch with me to do that. And I will stop there and hand back to Will. Thank you very much.
Thank you very much, Rach. Okay, so what to expect next? Just a quick reminder, we probably won't have time to answer questions live, so if you have questions, please do enter them into the Slack channel that you see up here. Each of the representatives will now talk for about 6 minutes, and we'll begin with Kat Volk, who will present the Solar System Science Collaboration. So, Kat, thank you very much.
All right, so as was mentioned earlier, here I am presenting on behalf of the co-chairs Meg Schwan and Dave Trilling. I know Meg is particularly active on Slack, so if you have questions, she is likely available to answer those. So the Solar System Science Collaboration has over 150 members. It's a pretty decent-sized collaboration, and we are focused on getting ready for the 5+ million solar system small bodies we expect to be detected in LSST with over 1 billion observations. I know in the outer solar system, which is my specialty, this is an order of magnitude better than any data set we've had previously. So we have a lot of work to do to get ready. And the SSSC is really about supporting everybody getting ready for that. At the bottom of this slide, there's a link to the Science Collaboration website. Anybody who's interested in solar system science is welcome to join the collaboration, and there is information on that site. So just a highlight of some of the recent activities. There's been a lot of focus lately on providing feedback to the SCOC for the cadence simulations, in particular reviewing the version 2 simulations that were done in response to the cadence notes in the white papers. We have a link here to our kind of summary document discussing how different cadence decisions affect different aspects of the discovery of solar system objects, their characterizations in terms of things like rotational light curves and photometric colors. So you can read those there. We are also in the process of putting together a paper for that app.js focus issue. So the collaboration members who put all of this really great effort, many on volunteer basis, into evaluating all the cadence simulations have written that up. We are currently just commenting on the full draft of the paper, so we expect to be able to hit that planned September submission of that paper. Working groups within the collaboration have also been ramping up their activity. Several of them have been having active telecons. I know there's like a software working group, an active objects working group, NEO working group. So those are also things you can join if you join the collaboration. We also had another one of our solar system readiness sprints that was held virtually earlier this year, where we worked on kind of mini projects. Everybody got caught up on the latest developments, working on things like putting together new models of solar system populations that we want to have predictions of what kind of data we're going to have. And again, there's a link there to the information and a lot of recordings. So Meg made my job easy. Plans for the next year, we're going to keep providing feedback, including on the Rubin early science plans, especially because decisions about templates and difference imaging and stuff has strong implications for how soon and what kind of solar system data we're going to get. We are also going to keep engaging with the SCOC for the final cadence decisions, and there's other preparatory work going on. Current data previews don't have solar system data products in them, so that is something the collaboration is working on, putting together sample data products that we can work on things like software tools. And also just getting people to talk. There's going to be a lot of follow-up observations needed for the detected solar system objects, so we need to start thinking about observing proposals to follow up facilities, both for the first year and longer time scale. There have also been a lot of discussions about funding opportunities, which was just mentioned as being really important. So I think that is the full solar system update. So I will now hand it off to the next science collaboration.
Thank you. My name is Federica Bianco, and I'm presenting on behalf of myself, my co-chair Rachel Street for the Transcendent and Variable Stars Science Collaboration, and all of our 400 and some members. The Transition Variable Star Science Collaboration is the second largest science collaboration, and the rate of growth is really staggering to me. We have doubled our size since the last time we gave this update in person in 2019. We're organized in subgroups because we cover a very broad spread of science, all of the objects that are transients or variables, so anything that changes in the sky. We have 15 subgroups dedicated to all forms, phenomenologies of these transients and variable objects. If you want to break it down, you can break it down in extragalactic, and some examples might be supernovae or fast transients, galactic, and some examples might be microlensing or pulsating variables, and methodological, and some examples might be multi-wavelength characterization and counterparts, classification, and the two newest ones, which are anomaly and true novelties, and data visualization and characterization. Instead of telling you more about our activities in general, I just want to highlight some of our most recent accomplishments and achievements. The first one, on the left of the screen, we have just uploaded on the archive, it's available today for the first time, our roadmap. So the Rubin Observatory LSST Transients and Variable Stars roadmap, which is a fairly hefty, couple hundred pages document, is available today on the archive. It's also available on our website that sadly I had to recognize I forgot to put on these slides, but perhaps Rachel can post it on Slack real quick. We have led many of the publications that have been mentioned earlier, collected in the special issue of the APJ supplements. 6 of the currently available 9 publications are led by TVS members. Every year we instantiate task forces to work on specifically urgent tasks and problems. And this year's the task forces were software, data preview, zero, survey cadence proposal, and metrics, crowded field photometry, which has been a long-standing task force within our group. We also have presence in 2 of the commissioning teams. And the last highlight that I want to mention is that we have in the context of the survey cadence proposal, the metric task force, we have produced reports for the SCOC, the Survey Cadence Optimization Committee. We have produced 3 reports. In fact, depending on how you count it, maybe even 4 reports to help them optimize the survey strategy in a way that supports transients and variable sky exploration. Let me spend a couple more seconds on software. I want to link back to what Rachel mentioned. We leverage the HSF grant, and we spun off a software task force to ensure that people can be not only trained in software, but that we have enough members that are trained enough in software that even if they're not software developers, they can support the in-kind contributions of software which we have received, which are many. And I want to encourage you to go to the in-kind session and to the IDAC session today, because some of our TVS members will present about some of those contributions. Finally, I want to end by focusing on something that has been really a strong drive and a strong point of focus for the science collaboration in the past few years. Justice, equity, diversity, and inclusion within the science collaboration. We have a group of Jedis that spearheads this effort. They have many activities. On our website, you can find our call to action, which was written in 2020 in the wake of the racial reckoning we had in the United States. Over time, we have tried to support members of our science collaboration that went through remarkable number of crises, socio-political crises in the past few years, including collecting resources for VLM, API, and the Ukraine war, and in support of people that are affected by Roe v. Wade. We want to provide training in diversity, equity, and inclusion for our members, so leveraging again the HSF grant. We have run a survey to understand what kind of training people want to focus on, and really what came out of that survey is that people are happy to focus on training on anything and in any modality. And we'll start by organizing a bystander intervention training and a few other training opportunities, facilitated training opportunities in the fall. 2 announcements to end. As part of our call to action, we want to understand our structure and our members and their experience within TVS better. So We're going to do that through a census. We've been preparing this census for quite some time, and it just went out this week. If you're a member of TVS, you should have received an email and a Slack message asking you to fill our census. Please do that. We do that in an effort to improve, to better know ourselves, and thus improve ourselves and be able to support you better. And you hear it for the first time here, unless you're a TVS member, and then you heard it in our subgroup, in our group meetings, that the two TVS chairs, myself and Rachel Street, we're stepping down this year. We are going to open a call for nominations today. We are going to have an election open for 1 month from October 1st to October 31st. We're going to elect a new chair on November 15th, and we're going to overlap with that chair. That shouldn't say October, that should say January. At the end, we're going to overlap with the chair. So if you're a member of TVS, please participate in the election and consider running for the chair position. And if you're not a member of TVS, why not becoming a member of TVS? We really are trying to just be a supportive and welcoming environment for any scientist's interest in exploring the transients and variable sky with Rubin. And I'm done.
Thank you very much, Fed. Okay, so I'll switch hats and represent Stars Milky Way in local volume for a few minutes. This collaboration has this very ambitious goal of understanding everything from the local solar neighborhood all the way out to the local volume, aided by LSST data. And so the structure of this group is set to help do that. You can see on the slide here some of the science working groups that we have sort of loosely organized around these themes. Currently there are 3 co-chairs, John Gizis, myself, and Peregrine McGeehee, although John will soon be rotating off, and so we are in the market for a new co-chair to replace him. Some example activities that SMWLV has done in last year, you can see on the slide here. I'll point out a couple of them. We've been holding regular, roughly bi-weekly hack days jointly with TVS and any other science collaboration who wants to join, and that's led to several cadence notes for the SCOC observing strategy process, as well as some new tools and some new collaborations. We're involved in developing LSST SMWLV science, of course, and a latest example of that is a new paper led by Leo Girardi's student, Piero Daltio, with a new population synthesis for the entire galaxy for LSST. We also use precursor data sets to do things like validate confusion limits in Rubin Sim, in this case using DECCAM data. And as first light starts to approach, we're working quite hard to revitalize the different science working groups to make sure that we try not to miss any science areas in this enormously diverse set of science goals that this collaboration actually has. So a couple of points I think it's worth making. I think it's accurate to say that for most of the science cases, the key Rubin data products we would be using would be the annual release object tables for at least the static science cases, but of course with difference imaging and force photometry light curves for the many cases that rely on variability, such as finding RLI reads, for example, the trace galactic structure, possibly direct images for custom reanalyses. But turning to challenges, we face a few challenges, I think, that are both technical and in some sense almost managerial. And so I'll do the technical challenges first. As I think Fed pointed out, we've known for some time that crowded field photometry with Rubin is going to be an interesting challenge. And so one area that this collaboration has worked on is to try to sort of advance point source photometry of crowded regions with purpose-built code to do these challenges. Looking in the galaxy rather than extragalactic, of course, there are lots of other challenges, including the fact that we've got this honking great bright foreground of nearby or bright stars, which have to be accounted for. And even in every other region, of course, star-galaxy separation is going to be a crucial challenge for the science that we want to do. Proper cross-matching, including awareness of differing uncertainties in external catalogues is another important point, and one that Tom Wilson here and Tim Naylor in the link there have been working on. We're working with them to try to improve that situation. In terms of management, we're all very bandwidth limited, and so SMWLV really wants to involve more people to help run the collaboration for things like, for example, membership, ingesting new members and onboarding people into this collaboration. So we welcome all input. If you'd like to contribute to SMWLV, please check out our website, or probably even better, contact one of the 3 friendly co-chairs. That's myself, or John Gizis, or Peregrine, to get involved. And our emails are at the bottom of the slide here. And with that, I think I'm done. So thank you very much, and I'll hand it over to Sugata for Galaxies.
Thanks, Will. Okay, so I'd like to give you a summary of what the Galaxy Science Collaboration is up to. So currently I chair the Science Collaboration. We have about 240 members from across the world. I'll come to membership at the end, but new members are always welcome. There are no requirements on time commitment. We have members from across career stages. So our core goal is to perform extragalactic science over cosmic time. So there are many advances expected from LSST, right? So there are the first is revolutionary statistics across essentially the full spectrum of galaxy evolution studies. There's this vast discovery space in what people often call the low surface brightness regime, right? So this is essentially faint objects and structures which are just not accessible in past wide surveys, like let's say the SDSS. So this includes things like dwarf galaxies at cosmological distances, right? So these galaxies dominate the number density at all epochs and all environments, so we need to understand them to understand galaxy evolution. Then there are then there is intra-group and intra-cluster light, right? So they carry significant fractions of the baryons in these types of environments. Faint galaxy outskirts, including things like tidal features, which tell you something about the hierarchical, allow you to test the hierarchical paradigm. Then there are statistical studies of rare objects or extreme objects, so things like starbursts, massive high redshift galaxies. And the study of these objects will be facilitated by combining LSST with ancillary data, for example, from the infrared in the infrared wavelengths. And finally, there's intersection with computer science, right? Because the simple fact is that the amount of data that we're going to have coming in from LSST and other surveys is going to probably render most of the classical techniques that we've used to analyze the galaxies, redundant, to at least, they will have to be so augmented by things like machine learning. So a lot of our members are involved in developing sort of AI techniques to be able to enable us to analyze the data that we're going to get from LSST. Okay, so some words on the structure of our collaboration. So we have 7 working groups. Some working groups are more active than others, but some of these working groups have their own collaboration meetings. They have challenges, data challenges, and so their job essentially is to develop the tools and the infrastructure that Galaxy Evolution, the Galaxy Science Collaboration members are going to be using to analyze LSST data and to do science with LSST data. And as other collaborations have pointed out, we have liaisons. So we provide input. So we have folks on the contributions evaluation committee. We provide input into survey cadence. We have members who serve on the Rubin Euclid working group. And we have liaisons for data management and commissioning. So recently we've appointed 2 in-kind operations managers, and they will be essentially looking after or providing scientific direction to our in-kind program. So let me finish off by just summarizing some of our activities. So a lot of our effort, I think a lot of our bandwidth is going to be going into managing the in-kind contributions, which are embedded in the Galaxy's SC. So here are some of the themes that we're going to be working on. So we are developing pipelines which will enable people to do low surface brightness science. So one of the things you have to do is to make sure that the sky subtraction that you're applying to the images doesn't actually kill off all the faint flux, right? Because if you do that, then you can't actually study objects in this regime. So a lot of effort is going into developing LSB, low surface brightness optimized sky subtraction algorithms to detect low surface brightness objects and structures in these images, and so on and so forth. Then there are pipelines for photometric redshifts and SED fitting, which will give you the physical parameters that you need, right, to study your galaxies, stellar masses, star formation rates, et cetera. And some effort is being devoted to developing pipelines which estimate morphological parameters, right, which tell you something about the structure of the objects that you're studying. We're also working on distance measurements. These are for nearby galaxies through things like surface brightness fluctuations. And then finally, well, last but not least, people are developing tools for cross-matching LSST with ancillary data, right? So, so we want to harness the power of these combined data sets, right? Optical plus radio plus infrared. So some of our effort is going into building the machinery that will allow us to do that. And we have, as I said, ongoing service to several committees, the CEC, the Rubin Euclid Working Group, et cetera. And we, so typically we meet via monthly telecons. So we also have some face-to-face meetings, and some of the working groups, as I said, have some data challenges. Okay, so basically I'm done. So I think the last thing to say is if any of this seems interesting, please join us. As I said, there are no requirements for in terms of time commitment. You can be at any career stage. We welcome everyone. We have a single tier structure. If you go to the website, click on apply for membership, you'll get the membership form. It'll take you probably about a minute to fill in. And then, you can get involved in our activities. A lot of the stuff happens on Slack. So once you do join, please join the channels on Slack. And yeah, we hope to see you in our science collaboration. Thank you.
I'm representing the Strong Lensing Science Collaboration. The co-chairs are Timo Anguita and Graham Smith, who couldn't be here today. So first, an overview of Strong Lensing Science Collaboration science. So we'll be looking at the mass and structure of dark matter halos, around 100,000 strong lenses spanning galaxies, groups, and clusters. We'll be looking at time delay cosmography, quasar microlensing, gravitational telescopes, where we can look at the resolved properties of high redshift galaxies, and the physics of lensed explosive transients like kilonovae gravitational waves, gamma ray burst afterglows, supernovae, and so on, and much more. These are some selected active projects in the Strong Lensing Science Collaboration. We are developing a strong lensing pipeline joint with the desk. Remy Joseph is leading that effort. We are developing a strong lensing discovery system, including machine learning algorithms, citizen science, fast modeling, and so on. We're building an all-sky watch list of lenses before survey operations, so we'll be ready for early lens transient discovery. Their in-kind contributions include an optimal image quality stacks for strong lensing discovery and a database of all known strong lenses, which is being developed by Fred Corbin et al. There is collaboration between the Strong Lensing Science Collaboration and the desk Strong Lensing group. There are these members that are joining the commissioning team. And there's also preparations for the foremost strong lensing spectroscopic legacy survey led by Tom Collett. These are our critical data observing requirements. We are looking for a single visit and stacked pixel cutouts up to 2x2 arc minutes as fast as the embargo allows. Non-standard alert packets for a defined list of targets, optimal image quality stacks for static strong lensing discovery, good seeing in one blue band in order to observe lens star-forming galaxies. We are hoping for an early reference survey for rapid strong lensing discovery and a full wide fast deep template image. A target of opportunity program, including deeper than wide fast deep depth, and we prefer survey area over cadence, as lenses are rare and strong lensing science is really exciting. So we collaborate widely across the science collaborations. These are liaisons, names of liaisons with the strong lensing science collaboration in various other groups or other science collaborations. And we are connected to the wider Rubin LSST ecosystem. So these are members of the strong lensing science collaboration that are active in other groups in Rubin LSST. You're welcome to join us. Anyone at any career stage with interests related to strong lensing enabled science is welcome to join. There's no minimum requirements for membership. We have a single layered membership structure. We hold regular meetings that are joint with the desk strong lensing group, and those are monthly, and more specialized telecons. We are looking forward to an inaugural face-to-face strong lensing science collaboration together with the desk strong lensing group. We're planning a in-person meeting coming up in the near future, so stay tuned for that information. We have a website you can visit here. If you have questions, please reach out to the chairs, Timo and Graham, and they're also monitoring Slack, so you can message them there. Thank you.
I'm Gordon Richards, representing the AGN Science Collaboration. We have 143 members. I would say most of the work probably is done by 15 or 20 members, but we're always looking for ways to encourage more people to get involved and to join the collaboration. So the link for the collaboration membership is listed there. We have a charter as of a couple of years ago that is based largely on the TVS charter and a three-tier member structure to go with that. Neil Brandt is the long-standing chair of the science collaboration since actually LSST started. I came on as a co-chair not long ago. We have 4 science-based sub-collaborations led by the people listed here, and a number of subcommittees that are sort of more technical and operational in structure. Of the leadership here, myself and Franz Bauer are here today, and a number of grad students, some of which you're going to hear about today, and then I'll have posters out in the hall. Core mission, as it says, is to maximize the AGN science return of LSST, give feedback to the project to make sure that we're doing the best possible AGN science, and educate the broader community about LSST AGN science. We're pretty good about having regular meetings. There's a monthly telecon, and the 4 science-based subgroups also try to have monthly telecons as well. We've also done a pretty good job, I think, even during the pandemic, about having regular meetings, virtual meetings in the last couple of years. The most recent one was just a couple of weeks ago. Those are recorded and on YouTube if anybody wants to watch those. And if you're interested in getting involved in a collaboration, I would certainly suggest going through those. We recently completed an AGN data challenge. So this was actually basically SDSS type data morphed into the LSST data model, hosted on SciServer at JHU. We're writing a draft paper on those results. That challenge is closed, but it's still open for people to work with the data set. There's a lot of work going on in terms of multi-wavelength data collection for the DDFs. We've done a lot of work for survey cadence optimization, producing a number of maps that are in use today. A couple of PhotoZ letters of reference, and then also a detailed road mapping document that is intended to be helpful for people applying for grants and appears on the main website where the membership link was. In terms of data products that we need, DIA plus force photometry light curves are certainly a strong need and interest. deblending with force PSF nuclear photometry as well, and PhotoZ specifically with AGN templates, and considering not just galaxies. I would say, probably a strong need is the ability to recognize that LSST is not just SDSS on steroids, and to be really working with data that's going to look more like LSST data than the SDSS data. Finally, in terms of challenges, certainly centralized computing resources is something that we are thinking about and concerned about. Like I said, the data challenge is hosted on SciServer. We would like to move off of that, and we've been having some discussions about what the optimal place would be for these activities. I would say biggest concern we have right now is really feel like we have insufficient funding to optimally engage with some of the things that are going on, right? Software engineers at Link, in-kind contributors, the Catalyst Fellows, cadence optimization, and so on. Probably need multiple PIs with sort of $50,000 grants really to support grad students to make everything happen the way we would like it to. But I would say despite those hurdles, there's a lot of excitement and a lot of activity, and I would encourage anybody of interest to come join us, talk to myself, talk to Franz, or the students you'll hear from later. Thanks.
Hello, everybody. It's very exciting to be here to hear about all the great work and plans ongoing by Rubin and the science collaborations. I am Katrin Heidmann. I am representing the Dark Energy Science Collaboration desk. And our scientific aim is to explore the secrets of the dark universe. We want to understand why the expansion of the universe is accelerating. Is it a dark energy, or is it a modification of gravity on the largest scales? We want to understand the nature, inquire what dark matter is made of. Is it interacting, for example, self-interacting? We want to understand about neutrinos, what is their mass. And also on Monday, you heard from one of the students about investigating signatures of inflation. Is there maybe a primordial non-Gaussian field that we can measure? Our objectives, they are listed on the desk webpage, and there's much more information about desk on this webpage as well, is to deliver accurate cosmology with the amazing data set that the Rubin Observatory will deliver to us. And accurate here, we mean we want to really increase the precision with which we measure cosmological parameters, like the dark energy equation of state, for example. We are building a vibrant and inclusive scientific community. This is very important to us. We are working very hard on meeting the LSST's big data challenges. Our analysis tools have to scale to the data sizes that we will receive. So we are focusing on that a lot right now. And we want to continuously learn from each other. For example, last week we had the desk collaboration meeting, and as part of that, we always have a dark energy science, dark energy school, where we learn from each other in different fields. And often we also have Rubin project manager members participating in the school. So this is really great. Our approach is combining 5 cosmological probes, clusters of galaxies. You actually see here on the right an image from DP0, and you have heard from Jeff yesterday in the plenary session, and he actually put together a notebook for DP0 to identify the largest cluster in DP0. So you see here an image of that. Large-scale structure measurements, clustering of galaxies, supernovae, weak lensing on strong lensing, and combining all of those probes to get the best cosmological constraints. Our challenges will be systematics, and we are working very hard on that, getting those under control. We have written down our science requirements in the science desk science requirements document, which you can look at on the archive. It's publicly available. And currently we are preparing with simulated and precursor data to really get ready for data arrival. We were asked a couple of questions to address on these slides, and the first one was, Rubin provided data products and tools that we will most heavily rely on. And as you saw on the previous slide, our probes are depending on the wide fast deep field measurements, deep drilling fields, as well as the alerts. So for the annual data releases, we need uniform co-edited images, especially years 1, 2, 4, 7, and 10. And they need to be carefully planned if the rolling cadence is what we decide to do as a community. And so we are working closely with the SCOC and with the Rubin folks to to realize that. In the time domain, we use the alert streams, prompt image products, the Rubin pre-discovery service, annual data releases with time domain reprocessing. So again, everything that will be delivered to us. The derived data products and tools that we are building or planning to use are value-added catalogs, including photometric redshift. So PhotoZs are one very important ingredient for us that we have to get really accurately. Database of high likelihood supernovae and other interesting transients, together with auxiliary data like spectra and host galaxy properties, and algorithms for photometric classification and spectroscopic follow-up scheduling with an active learning loop. We were also asked to talk about our core challenges and uncertainties we are facing. And as I already said, photometric redshifts is one of them. This will require for us spectroscopic redshift samples. And I think there's a great opportunity with the in-kind program for collaboratively defining what these follow-up spectroscopic, or what the spectroscopic samples could be, for example, with Subaru PFS. So we would be happy to talk with all of you more about that. Blending will be a major challenge for us. So we are looking forward to scarlet light tests. We heard a little bit about that also last week during the desk collaboration meeting. So that's really exciting. Photometric calibration is important for us, very important for us to get that very accurately. And shear measurements. So for weak lensing, obviously, they are very important. And so, for example, we are working on meta-detect, and we work again together with the Rubin project to see what are the best possible algorithms that we can implement to make this happen. Becoming a desk member is very easy. We welcome everybody here. Currently, we have more than 1,200 members, still growing. 240 of these are full members. And the only thing you need is LSST data rights. And so most of you know, you can get those either if you're at a US or Chilean institution or via an international MOA. For desk membership, you can click on this link. Again, it's on our webpage, so you can apply. We also don't have any, besides the data rights, no more requirements for you. And the only thing that you have to do is you have to you have to sign that you will follow our code of conduct and the LSST desk publication policy. And just in the last 5 seconds that I have on the right here, you see another project that we are working on where we are comparing DP02, which you have heard during this meeting a little bit about, is a simulated data set that has been processed by the Rubin team, and DC2, which is the same simulated data set processed by the desk team with an earlier version of the stack. And what we are preparing right now are tools where we can actually see how these different stacks compare with each other. So here you see a comparison of the number of galaxy density per square arc minute from DP0.2 and DC2. And basically, we are developing these tools also to help us to decide how our galaxy samples for our cosmology will look like and make these decisions. And again, it's something where we can work very nicely with the Rubin team together on verification and validation. So we're very excited about that. Thank you.
Hi, my name is John Franklin Crenshaw. I'm presenting on behalf of the ISSC, or the Information and Statistics Science Collaboration. The ISSC is a little bit different from the other science collaborations you've heard from today, because rather than focusing on particular astrophysics or cosmology questions, instead we focus on science-enabling methodology in the information sciences. ISSC membership is strongly interdisciplinary, with a large percentage of members from the information sciences, such as statistics, machine learning, computer science, etc. And we aim to enable and enhance interactions between astronomy and the information sciences, and to provide opportunities for consultations with astronomy-focused data science experts, interdisciplinary research in astrostatistics and astroinformatics, and coordinating data science work that cuts across the different science collaborations. Most astronomers that are in the ISSC are also members of other science collaborations that align with their more specified science interests, and that's depicted in this network diagram. The colored dots represent ISSC members that are members of more than one of the other science collaborations. The information scientists that are members of the ISSC are mainly observers and consultants on projects that are led by astronomers, and they're looking for more opportunities to contribute to these projects. Most of the active work by ISSC members is taking place in collaboration with the other science collaborations. And here are just a few examples of that work, which involve the strong lensing and dark energy science collaborations. And the bolded names on these slides indicate ISSC members. Youngsuk Tak, who manages the ISSC webinar program, led a response to the strong lensing time delay challenge, including ISSC member Aneta Sigmanoshka. Their team used Gaussian processes to measure time delays in strongly lensed systems, and their submissions was one of the best performing algorithms in that challenge. The other two examples are from the ISSC Ambassadors Program, which was funded by an LSSTC Enabling Science grant to strengthen ties between the ISSC and the other science collaborations. Each project was co-mentored by an ISSC member and a member from one of the other science collaborations. So this first project involves analysis of HSC images using a new method for detecting and querying morphological features like galaxy shapes and tidal tails. This was led by ISSC Ambassador Alice Simon, who was advised by Francois Lanous from the ISSC, who's also a desk member, and Sarah Bra from the Galaxies Science Collaboration. The second project studied how imperfections in PhotoZ training sets can impact the performance of a specific PhotoZ estimator that uses Gaussian processes. And this was led by ISSC Ambassador Natalia Stalianu and advised by several people, including myself and Alex Maltz, who were both ISSC and desk members. And this project is a precursor to an upcoming PhotoZ data challenge that myself and Alex will lead in collaboration with the Dark Energy Science Collaboration. The ISSC is managed by co-chairs, Tom Laredo, an astronomer, and Chad Schaefer, an information scientist, plus an interdisciplinary core team of 5 members that you can see on that slide there. The ISSC episodically hosts webinars, mainly with presenters from the other science collaborations, introducing challenging data science problems to the ISSC membership and seeking advice and consultation from the statisticians, the data scientists, and so forth that live in the ISSC. And the ISSC also works with other science collaborations on LSSTC enabling science projects and contribute to cross-cutting efforts like the Event Broker and Survey Cadence workshops. And the ISSC is currently working on drafting a new charter, so now is a good time to get involved and help plan the future of the collaboration. Thanks.
Okay, thank you very much, John, and thank you very much to all of our speakers for remarkably keeping on time. Thank you to the speakers that stepped in to present on behalf of our science collaboration chairs who couldn't be here. So let's give everyone, all the speakers, we have a few minutes before we hand over to the student presentation. So I do want to make one more presentation. I'm going to embarrass Fed by asking her to come up. Please, and I've just realised I've forgotten the thing I was going to present, so excuse me. So we wanted to recognise Fed Bianco, who is the outgoing science collaborations coordinator for your tireless leadership, empathic and effective in many ways. And since you became science collaborations coordinator in 2017, I think it's fair to say you've revolutionised the collaborations. So on behalf of all of us, thank you so much, and best of luck with as Deputy Director. So thank you very much, Fed.
Thank you. Thanks, everybody. And I think all the science collaborations will be very happy to have a coordinator that is as well organized as Will. And I think he demonstrated that today, just from the start. Thank you so much.
All right, so thank you all very much again. If you'd like to join the science collaboration, you can see the link on the slide here. And Thank you all very much. Now I'll hand it over to Pat Burkett and the student presentations. Thank you all. Okay, great.
Yep, thank you. Okay, I think the science collaboration overviews were a great introduction to the poster topics that you're going to be hearing about now. Here's a picture from last night of most of the students who are attending. On Monday, you heard from about a dozen undergraduates and about a half dozen graduate students. The undergraduates, unfortunately, are leaving today. They're very sad to leave. And today we're going to hear from the rest of the graduate students. So go ahead, Nadini, first.
Good morning, everyone. I'm Nandini Hazra. I'm working with Michele Cantiello and Marica Branchesi at the Gran Sasso Science Institute and ENAF of Abruzzo in Italy. I'm working on using surface brightness fluctuations from unresolved stellar populations as a distance indicator for Rubin. And we're developing a pipeline that will measure fast, accurate distances with minimal human intervention. If you'd like to chat about distance indicators, please drop by my poster.
Next, Irene.
Right. Hi, everyone. I'm Irene. I'm going into my third year at Rutgers, and I work with Erica Weiser. I work on answering the question of how we can best select an optimal sample of galaxies and then sort those galaxies by redshift for computing angular two-point correlation functions for galaxy clustering. The figure up here summarizes my main results. It would take way longer than 30 seconds to explain it, so if you want to know more about that, or if you have absolutely no idea what a two-point angular correlation function is, you should come to my poster.
Hello, everyone. I'm Riley Clark. I'm a graduate student at the University of Delaware, and I'm working with Federico Bianco as well as Jim Davenport from the University of Washington. Stellar flares are short-lived transients that last from a few minutes to a few hours, and because of this, Rubin is unlikely to detect flares with more than a single data point in the Wide Vast Deep Survey. However, by taking advantage of an atmospheric phenomenon called differential chromatic refraction, we can infer the spectral energy distribution and temperature of the flare and enable statistical studies of flare temperature profiles for a massive sample of flares over the survey lifetime. So if you'd like to learn more, please stop by my poster. Thank you.
Pratik.
Hi, everyone. I'm B. Pratip Day, a grad student at the University of Pittsburgh, working with Jeff Newman and Brett Andrews. If you are looking at other galaxies using the Rubin Observatory, you probably care about how far they are. That is, you want to know their photometric redshifts. But how do we know that they are correct, or how can we ensure that they are actually statistically well defined? That's what my poster deals with. Feel free to visit us. And if you care about any kind of prediction problem, be it photometric redshifts or your weather prediction, you might be interested in my poster. So see you there. Thank you.
Ben?
Hi, I'm Jalin Kopp. I'm the first-year grad student from the University of Arizona working with Ann Zabdov. My research addressed classifying transient using only host galaxy apparent magnitudes and colors from 10 photometers band. Our parameters may correctly classify around 60% of LSST alert. And each night, we anticipate correctly identify 1 to 2 tidal disruption events and around 10 to 1,000 supernovae depending on the subtype. So then what I found, come to visit my poster. Thank you.
Hi, my name's Lauren Alderodi. I'm a fifth-year graduate student at Texas A&M working with Li-Fan Wang. My poster today is about using neural network predicted principal component decompositions of type 1a supernova spectra to generate a fake LSST data set and eventually apply that to a cosmological analysis. So come chat with me.
Ruby?
Hi, everyone. My name is Ruhi Bilal. I'm a graduate student at Princeton, and I am leading the weak lensing cosmic shear analysis in Fourier space for the year 3 data release of the Hypers to Prime Camp survey. HSC is the deepest Rubin precursor survey. It's only about 1 magnitude shallower than the full LSST depth, so our analysis will really help inform analysis choices for future Rubin work, including PSF systematics, how to handle blending, and how to model baryonic effects and intrinsic alignments. So I'd be happy to talk about how we're approaching these choices and other aspects of the analysis at my poster. Thanks.
Hello everyone, I'm Javier Silva Farfan, last year master student at University of Chile. I have been working with Francisco Foster on inferencing physical parameters from type 2 supernova light curves using data from CDF and Atlas. And with our method, we estimated physical parameters from a sample of roughly 200 supernovae using only photometric data, and we were also able to estimate the redshift using only this data. So our method is really flexible and is currently being adapted to be used with data from LSST. Thank you.
Amanda?
Everyone, I'm Amanda Wasserman, a rising second-year graduate student at the University of Illinois at Urbana-Champaign, working with Gautam Narayan. And my research involves recommending supernovae for spectroscopic follow-up after they've been discovered photometrically by LSST. And our goals for this are to build a better training set for photometric classification and to further understand the physics and progenitor systems behind transient events like supernovae and kilonovae. So I'd love to hear from you all if you want to stop by my poster later.
Vincenzo?
Hello everyone, I'm Vincenzo Petrecca, PhD student in Napoli, and I mainly work on the analysis of archival and simulated data to get ready for early science operation with LSST, trying to limit all the uncertainties which may affect the interpretation of Rubin data. If you look at my poster, you will see 2 test cases. The first one with preliminary results on the measurement of the supernova 1A rate using the DC2 data, while the second one is an application with some way to select AGNs through variability as part of the data challenge organized by the AGN Science Collaboration. So if you want to know more, please reach me outside.
Hey everyone, I'm David Wang. I'm a second-year grad student working with Eric Bellum at the University of Washington. Look for X-ray binary outbursts in alert streams. So we deployed a real-time transient search that subscribes directly to the ZTF alert stream, and we cross-match alerts to the positions of known X-ray sources and calculate an outburst metric based on the exponentially weighted moving average of previous observations. So if that sounds interesting, please talk to me on my poster.
Wei Zhang?
Hello, I'm Wei Zhang Yu. I'm a final year PhD student from Drexel University working with Gordon Richards. So my research is about the classification, photo-Z estimation, and variability characterization of AGN using the multifaceted LSST data. We built an exploratory data set of 500,000 sources cross-matched against multi-wavelengths and time domain surveys to help develop and test algorithms that will take full advantage of the multifaceted nature of upcoming Rubin data. This is actually the data set that was used to run the AGN data challenge. If you are interested in the research questions I'm about trying to address or want to learn how this data set may help your science, please come and chat with me in my poster. Thank you.
Shu?
Hello everyone, my name is Shu. I'm from University of Pittsburgh. I work on testing and improving the dark energy science collaboration difference image analysis pipeline. If you are interested in my work, please come and visit my poster.
Antonio?
Hello, my name is Antonio Vanzanella from Partenope University, and I study machine learning. I show here the work that I've been working on my master thesis, and the goal of the project is to work on the simulating small moving object, where such as long period comets, using machine learning methods. In particular, we use a convolutional neural network on the DP0 simulated image, on which we injected a small moving object. If you're working on a similar problem, I would love to chat, so come to my poster.
Natalia?
Hello, my name is Natalia. I am a graduate student at the University of Oxford, and I tested how bad machine learning photometric redshift estimates get under two realistic scenarios of training set degradations. So I used the code GPZ and data with LSST photometry, and I found that there's a drop-off in the quality of photo-Z estimates when we have above 1% spectroscopic redshifts and below 1.5 redshift incompleteness. So if you want to know more about that, then come chat to me up in poster. Thank you.
Shreya?
Hi, my name is Shreya Anand, and I'm a rising fifth-year graduate student at Caltech. I work with Mansi Kasliwal and a team of astronomers in identifying kilonova counterparts to neutron star mergers with the Zwicky transient facility. And one of the biggest challenges we faced in LVK's third observing run was to try to effectively photometrically distinguish between kilonova candidates and their imposters. This is going to be an even bigger problem in the LSST era when we do target of opportunity follow-up. So if you're interested in hearing about lessons learned from O3 with ZTF or interested in sharing your ideas, I'd love to hear them. Please come by and chat.
Hey, Priscilla.
Hi, I'm Priscilla Bea. I work at the Catholic University at Chile with Franz Baue. We want to investigate the driving mechanisms for AGN variability. We are working with the ZTF G and R band, and we want to correlate the variability properties with the black hole properties. And if you're interested in any of that, come see us, please. Me and my poster outside, and the rest of us, please.
So I just wanted to mention that the posters are gradually being uploaded to the session pages for the Monday poster session and the Wednesday poster session as PDFs. So even after the poster sessions, you can still go see, you'll be able to see most of the posters there. A huge thank you to the LSST Corporation for making it possible to bring 34 students fully supported to the 2022 Project Community Workshop. And I mentioned a couple of names earlier, Sherry Winfield for handling many logistical details, and Erin Carlson for all her help with arranging travel for all the students. And also all the research advisors for mentoring the students and the institutions for supporting the student research programs as we prepare for Rubin Science. So thank you to all of those. And as we finish up here, the posters are going to be in the same place that they were on Monday, out here. And again, make sure you go all the way to the end, okay, so that we get people looking at all of the posters. And the copy is out there. There's going to be a line for the copy. So some of you might want to go to the posters first, okay? So go in that direction. And I think that's all. Oh, there's a question from Jelko. Oh, okay.